The objective of this lesson is to compare fraction multiplication expressions without evaluating them. In the previous lesson, we explored the relationship between the size of a product in a multiplication equation and the size of its factors. In this lesson, we will build upon that experience as we look at sets of multiple related expressions. The first situation reads, during the school fun run, Hadley ran 3/2 the distance that Kennedy ran. Laney ran 3/4 of the distance Kennedy ran. Place the runners in order from longest run to shortest run. In this problem, we do not know the exact distance of any given runner, but since we know the relationship of each runner to Kennedy's distance, we can create a visual model to help us identify the longer and shorter distances. The red box represents Kennedy's distance. We already know Hadley ran a greater distance than Kennedy because she ran 3/2 of the distance, which is a value greater than 1. We can add Hadley's distance to our chart by dividing Kennedy's distance in half and showing 3 1/2 pieces. Hadley's distance is represented in blue. Similarly, we know Laney ran 3/4 of the distance Kennedy ran. 3/4 is less than 1, so Laney's distance will be less than Kennedy's. By dividing Kennedy's distance into fourths, we can identify the 3/4 mark and add Laney's distance to our model represented in green. Using the models, we can now respond to the question by placing Hadley first with the longest run, Kennedy second, and Laney third with the shortest run. Remember, we can determine the relative size of the product as compared to one factor by looking at the other factor. For example, 4 multiplied by 1/3. Without evaluating, we can state that the product will be less than 4 because 1/3 is less than 1, meaning we only have part of 4, or that we do not have a full 4. We can also state the product will be greater than 1/3 because 4 is greater than 1, meaning we will have more than 1/3 in the product. The next problem asks us to order the expressions from least to greatest without evaluating them. The expressions are 3 multiplied by 1/2, 3/4 multiplied by 1/2, and 3/2 multiplied by 1/2. To begin, it is important to recognize that each expression contains one factor in common, 1/2. This means we can compare the sizes of the uncommon factors to help us place the expressions in ascending order. The uncommon factor in the first expression is 3. Since 3 is greater than 1, the product will be larger than 1/2. The uncommon factor in the second expression is 3/4. Since 3/4 is less than 1, the product will be smaller than 1/2. The uncommon factor in the third expression is 3/2, which is equivalent to 1 and 1/2. Since that is greater than 1, the product will be larger than 1/2. 3/4 is the only uncommon factor less than 1, so we can identify 3/4 multiplied by 1/2 as the smallest expression, though it may be helpful to represent each expression visually. 3 multiplied by 1/2 is 3 1/2 sized groups, or 3/2. 3/4 multiplied by 1/2 is not a full 1/2 sized piece. It is only 3/4 of that 1/2 sized piece, or 3/8. 3/2 multiplied by 1/2 is 3 1/2 of 1/2 sized pieces, or 3/4. From smallest to largest, the expressions are 3/4 multiplied by 1/2, 3/2 multiplied by 1/2, and 3 multiplied by 1/2. Notice that when one factor is common to multiple expressions, the larger the value of the uncommon factor, the larger the product. If we were only to rank the uncommon factors from smallest to largest, the rank would be identical. Now, let's look at 3 problems that are missing a numerator. Each expression is an unknown quantity of fourths multiplied by 6. We must determine a number for each numerator. The first has a product less than 6, the second has a product equal to 6, and the third has a product greater than 6. Remember, for the product to be less than the value of one factor, the other factor must be a value less than 1. That means we could place a 1, a 2, or a 3 in the first expression to make it true, since 1/4, 2/4, and 3/4 are all less than 1. Next, we can recall the identity property of multiplication that states a number multiplied by 1 results in a product equivalent to the number. The only way we can create a true statement would be to place a 4 in the numerator, making it 4/4, or 1 whole, multiplied by 6 is equal to 6. Last, in order to create a product greater than 6, we need to multiply 6 by a factor greater than 1. In this case, we could use any number 5 or larger. Clearly, this could be a lot of different numbers. Anything 5/4 or greater would make the statement true. The objective for this lesson was to compare fraction multiplication expressions without evaluating them. We met this objective by looking at a variety of multiplication expressions with common factors. We made conclusions about the relative size of each product based upon the uncommon factors. In some cases, it was helpful to create a visual representation of each expression.